In this chapter, we'll cover building rich shaders and texturing for digital sets. Being that digital set work is largely about lighting and texturing, shading should never be underestimated for how crucial it is to the success of your scene. Good texturing can convey scale and age and weathering to surfaces that are so important in digital set work. So the purpose of this chapter is not to teach the basics of creating shaders and texturing, but rather point out some of the techniques that do apply towards digital sets that you may find useful. So some of the topics we'll cover in this chapter will be using procedural or mapped approaches towards building your shaders, how to build basic shader networks and using color offset and gain to do so, creative use of the ramp tool, which is one of the mainstays of shaders, the use of specular maps, which for digital sets I think is crucial, and the use of triplanar projection, which is a absolutely amazing way to quickly texture a vast amount of your buildings and set pieces. And then lastly, we'll talk about a quick little exercise to show how to create weathering and age and surfaces using layered shaders. So we'll start by talking about texture maps themselves. Most artists keep a large collection of texture maps, and these days with digital cameras, architectural surfaces like this are very easy to acquire at a very high quality. So it's a good idea to keep a large collection of various types of textures of architectural and natural landscape surfaces around. The main thing about these, though, is that you may make a decision to use a map or to do a procedural method to enable the same thing. And some of the exercises that I teach are using procedural methods to replicate some of these sample textures. So if you're not comfortable with recreating some of these in the Maya shading environment, you may want to review some of the basics of shading networks so that you have the ability to create some of these on a procedural note. So in the Maya shading environment, there's plenty of ability to recreate, say, all this surface detail. The geometry patterns can be done using tiled ramps as a geometric kind of device. The noise, the decay in this can be done as with fractal noise that's multiplied and added with ramps. And basically everything you see here can very easily be created on a procedural by procedural methods. But that's not to say that procedural methods should be solely relied upon. Texture maps actually prove very useful for digital sets and backgrounds because they get us very close to a photoreal result pretty quickly, and there's just a vast variety of architectural surfaces to be had as texture maps. But the main disadvantage of texture maps is that in using them with digital backgrounds and sets, it's not uncommon to have hundreds or perhaps thousands of textures. So in this case, memory management tends to be a real issue. So your choices there are either to carefully optimize the textures to screen space of the camera, or to use true mipmap texture formats such as a .bot with Maya or a .map with MentalRay, or rely upon procedural methods as a way to alleviate the memory load, being the procedurals are very low on RAM, but very the trade-off, of course, is with higher CPU cycles. Now, the beauty of texture maps also is that they're very art directable. So within Photoshop, you should be very familiar with how to manipulate different textures to, say in this case, extract a hue of the rust out of a rusty concrete and apply it over a metallic surface, as well as add dirt layers and graphic layers and so forth. So Photoshop excels as the tool of choice for texture creation, and it's no different with digital set work. Here's a case of texturing applied towards environments that is very straightforward, but is very useful for environmental concerns. Here there's a rock face from Zion National Park, and a Hawaiian landscape below, and then merge together to create a unique type of natural texture, as well as skies that can be manipulated to create more of a fantasy setting. So starting with straight texture mapping, the usual skills of that apply towards digital sets. The only important thing is the use of specular maps, and proper bump maps do influence a lot of architectural work. So let's start by looking at a very basic file, and we'll show one very quick technique in Photoshop that can make a real difference with this. So to show this technique, what I have is a very simple wall surface, and we'll just apply a basic color map to it. Okay, and this has a nice variation in hue and relief within the map. So now let's go back, actually let's go into Photoshop at this point and see how to prepare proper maps. So over in Photoshop we have the texture map loaded, and what this technique shows, simple as it is a better way of creating spec and bump maps from textures rather than using the texture itself in grayscale mode. So the common thing you may see frequently is the same map used again for the bump, and the problem with this is that the bump is based on given lighting in this case. In other words, this is being lit from the upper right, and the shadows will, within the relief of the texture, will convey that. If we take this in, use this as a bump map, and then create our lighting from, say, screen left, we'll have a natural conflict between those two forces. So psychologically, we want to always have the bump be driven by the lighting. So in this case, what we can do is we can use a hue extraction or a selection mode to extract ranges of hue out that really don't have a lot to do with lighting, and we'll begin to use those for maps. So the easiest way to do this is go to Select Color Range, and what I can do here is sample different colors. You may have looked at this command before, and so right here you can see I can get a very idiosyncratic type of result from this that has really nothing to do with the arrangement of the relief based on lighting. So I'll choose this as a selection, and we'll save this out as an alpha, and I arrive at this. Now a lot of times using color range will give you a very kind of speckly result, and you can use median or different filters. One that I like to do is go into despeckle and knock it down a bit. But here's some examples now of bumps which were extracted from this, and the nice thing, this can be a spec also. So here we could have a bump map, here we could have a spec map, or perhaps a variation on that. So let's now go back to Maya and try some of these out. So back in Maya, we've only applied a color map, and we can see that this is not too successful because it does have a continuous specular sheen on the surface and no real bump rendition. So let's place one of the bump maps in here. And we will need to invert this bump. And let's knock it down. You can use the alpha gain as a way to knock bump down just as well as bump depth in the preceding node. Okay, so now I have a result that is pretty much in concert with the original texture as far as the darker regions being bumped back. There's still a lot of imperfection that needs to be put in this, though, so the best way for us to do this is through specular maps. And specular maps tend to be the real underdog in architectural maps. It's the way that materials are discerned from each other, and basically another great way to add some erratic behavior to a material surface. So under specular color, let's apply a map. And we'll now go back to one of the ones we just created. And we can see here we need to invert this as well because we're getting speck in the shadows and not in the painted region, which is what we're after. Alright, and then the gain on this will need to come down substantially. And again, this is treated as a color gain, not an alpha gain, because this is RGB color information. So this is getting slightly better, but still needs a lot more imperfection. Both to kind of break up the planarity of the wall. What I'd like to do is enhance this, make this look a little less planar, as well as take the speck that's there and make it more erratic as well. So we can do this by mapping noise to the speck and creating other noise added to the bump map. So within our bump file, we have a color gain and color offset available. And again, even more important than using these as a just as a multiplier or way to raise kind of a pedestal, these are better thought of as ways to build shader networks from. So in this case, what I'd like to do is add another bump to this, and I can use the color offset to do so. Again, the offset is strictly an add command, and therefore is unaffected at the value of black being 0. So in this case, I'll take in a noise map. And I think what I'll do now is go over to to speed this up. For some reason, we have very sluggish IPR behavior here on one NURB panel. I'll go ahead and move this over to a non-IPR comparison. So here I have my original bump, and we can see it's still very planar in nature, though it does have basic surface definition. But by adding a noise function through the offset, again adding this cumulatively to the bump, also using a billow type, so it's kind of a cellular based noise, I can buckle out the wall a bit like this. And this helps a lot as far as just providing a little bit more surface detail and imperfection within an otherwise planar surface. And because this is added as an offset, I have individual control for the level of this bump against the basic surface bump. So that's a nice thing. Let's go back to the specular map though, and we'll go into the map that we've already applied. And let's now go in and let's add, let me back up here, let's go do the same thing, but in this case we're going to go to the color gain. So in this case I want to negate the specular down from what it was consistently. So again, what I've done is under the gain, we've gone to a noise feature again. In this case, I'm using Perlin. I want this to be a little less, more smooth and less cellular in nature. And now let's look at a comparison of before and after on this. Okay, so this is the wall surface without the fractal map or the noise map onto the spec. And here we have it with. So it's a subtle difference, but we can see that now the specularity is reduced in certain areas, and again it just adds a little bit more richening to the image. So those are some basic techniques with texture mapping, but certainly if you apply this throughout your surfaces in your digital set, things will get a lot more richer, and they're very straightforward but easy to implement, and I think it will help your renders. Another topic I'm not going to put too much time on, but is worth mentioning in this, is the use of the ramp as a creative tool. And building shader networks is very powerful in Maya, but kind of hinging a lot of it on the ramp tool is especially powerful. The ramp has an ability to create geometric pattern and repetition, and that can be very useful for architectural sets. But this is just one example of a rendering done exclusively with ramps and procedurals, creating a fair amount of detail that otherwise would have taken some time by hand. So again, the ramp is being able to map different maps to the slider within the ramp. Each slider in itself is very powerful and offers great flexibility for digital set work. The next topic we'll cover is that of triplanar projections, and I think this has just huge import for digital sets. I've been able to shave off so much time and shade very efficiently and quickly with this technique that I think it's really worth mentioning. And we all know a basic planar projection which projects along the normal of the projection icon. And that's fine, but what a triplanar does is it replicates that on all three axes, and depending on the orientation of the object, if the object begins to rotate here, say in Z, that once it crosses a 45-degree threshold, this top face then picks up this planar projection. This is something that's never used for character work. It makes no sense for anything organic, and that's why this is not really heard about that often, but it's been in Maya for quite some time. But for orthographic models, it has huge importance, because now I can begin to shade or texture all three of these surfaces automatically, as opposed to going in and projecting individual faces. So if we look at this file, this is again the Indian stone temple. This was done with effectively two shaders, one shader for the bulk of the massing here, and then one done for the base kind of low wall, which had a slightly different texture. But effectively, this whole thing was done incredibly rapidly. And here we can see, although the beauty about this is that the tiling is not that obvious, the same texture map being projected from this face as well as from this face onto that face. And the only thing about this, when you have bevels that are have a 45-degree chamfer on them, they can get confused by the placement of the planar relationship, that 90-degree angle. So it's a good idea to take that planar projection icon and slightly rotate it just a degree or two to kind of ensure that your bevels hold steady through a range of animation frames, because that can be a problem. But again, in general, it just tends to work very, very well, especially for something like this where it appears to be out of a monolithic piece of rock. And this can work for castles and any type of stone, stucco, brick, just a variety of set finishes. Here's another example where the triplanar was used extensively to shade just about all the wall surfaces. And in this case, it had to be a brick coursing that had to be consistent throughout the model. It's even up here in the ceiling, though it's not too visible. But in any case, the trick on this is that the plan section on this varied quite a bit geometrically. So here we have kind of a typical orthogonal arrangement, then we have a half cylinder, then we have it rotated 45. The typical standard way of doing this would be to set up different projections for each face. But again, by using a triplanar, this whole thing can be mapped out at once, and it will all be proper in scale with each other, and that's the other beauty of this. So going back here, we can see the same brick scaling applying throughout. Now the other thing is triplanar is often confused with cubic mapping, and it's actually very different. Cubic mapping emanates from the center out, and triplanar kind of holds the scale on each of the three faces. So that's again why it's a just a terribly useful projection type for sets. And this image shows the use of triplanar maps for more urban type of facade texturing. We're going to use this in our final project, and we'll move over to that shortly. But here we can see some repetition among these maps. But again, the beauty is each one of those building faces did not have to be kind of dealt with separately. Rather, entire volumes were textured, basically in one fell swoop with the shader. So it's a very fast way of kind of roughing out a lot of detailed texturing in urban environments. And the last topic we'll cover with shading and texturing is that of weathering surfaces. And this is another very useful technique for sets and backgrounds, because you don't generally want to show them as off the factory floor. They generally need to have a lived-in appearance and be very realistic to the real world. So in this case, what's happening here is this exercise will show a basic CMU block wall, and then using procedural techniques, weathering it out to the one on the right. The last topic we want to cover is that of weathering surfaces for digital sets. This is a very important topic with shading because it's so prevalent, especially in film work with backgrounds. Very rarely would we want to show an environment as being surgically clean. So in this case, we can use a lot of Maya procedurals to aid this. Here on the left, we have a kind of an original concrete block wall, and on the right, one that's been treated basically by a series of procedural techniques to weather it out. And all these can be animated or modified in any type of way. So there's great creative potential with this. So let's look at this example very quickly. So here we are in the working file for this. This is the same wall setup scene that we had last time, just some different shader work. So we start off with a basic color map and a bump map, and we're going to start off with the grouting of the blocks being projected outward, and we'll go ahead and change that as we go. But let's go ahead and start by creating a layered shader, and within this layered shader we'll have 3 layers: one wall, one streak dirt, and another ramp dirt. And let's take a look at the wall, and we can see that's really nothing more than the color in the existing bump map. Now the color map, the first thing we can do though is we can do a color remap of that to get more of an eroded or recoloration effectively of the color map. I can see in here that this has some luminance range, in other words some variation. Here's a lighter block, here's a darker block. So I can use a color remap to enhance this, and color remap is another one of these great tools that once you begin to use it, you'll use it quite a bit. And what it will do is it'll remap the tonal range of the texture map with a ramp. And in the ramp you can either apply other textures or other colors in a means to effectively change the image. So it's just an easier way of modifying an image and going into Photoshop. So what the color remap gives me again is a new distribution of the tone. If I put in, normally this would be a black to white gradation, but in this case I've added some intermediate ranges. I'm kind of inverting the lookup table as it goes. So this is not unlike doing a curve operation in Photoshop and being able to manipulate tonal behavior. Alright, so that's one way to discolor the wall, but the other thing we want to do to age this is have more pitting and more kind of degradation in the wall. So let's go back to the bump map, and here we have the original texture map for that, but in this case now I'm adding a further bump, just like we did on the previous example, but through alpha offset. But now I'm using a fractal map that's thresholded fairly high, and threshold again is another very useful parameter with a fractal, so that now I can have an effectively smooth surface, but I can get gouging and pitting within the surface, and that's very useful. And I think I've inverted this as well, so that now I'll get, rather than a positive extrusion on this, I'll get it negatively kind of pitting back into the wall. Okay, so let's go back up to our base layer. We'll go back to layered shader. And that's what we've done to the base wall surface. Now we need to add some discoloration, or rather some dirt streaking within it. So if we go to streak dirt layer, and again this is like an onion skin where the rightmost one is the base and these are shells up above, dictated or driven rather by the transparency. So if we now go into this particular file, we can see this is a straight black color for dirt, but it's driven by transparency. So very, very simple. And in this case I'm using a fractal map to drive it. Now this is a 2D fractal because this is a very simple planar exercise, but in many cases you'll want to use a solid fractal routine as opposed to 2D, namely for the fact that your dirt will be globally scaled properly. So as objects go bigger and smaller, you're not going to get an effective change in dirt size. It would be more of a uniformity. So that's another nice trick. But in any case, this is thresholded again up high, and the repeats on this, actually let's go back here, are set so that it's very streaky in nature. So they repeat 2 here and 0.05 there, and that gives me this kind of taffy-like streaking. So here I've taken out a ramp that was applied here just to show you the before. And if I have this noise now, which is fine as a start, I need to erode it back at the base. So now I need a gradation of this, kind of streaking starting at the top and going down low. So in this case, I add a color offset, and because opacity is inverted in Maya black and white, oddly enough, we can go do this through the offset rather than the gain, which is normally used to degrade or remove aspects of textures. So in this case, we'll go to the offset, and I'll add some white at the bottom, which again will in effect remove it through opacity, and go up one, and now we can see we can get the streaking down, which is going to be a better appearance. Okay, from here let's go up one node, and you may have saw this earlier. This is a clamp utility node which has been placed in the connections mostly to enable a maximum value to be held, otherwise known as a clamp. And in this case it's can range anywhere from min 0 max to 1. And what this does is ensure that the value that I give it, and we can see the input is actually exceeding 1 here based on my ramp and my offset. It ensures that the opacity is maximized or normalized within that range. Otherwise I would get a ghosting of opacity or through the opacity channel. So this can be a very useful utility node along the way. Okay, let's go back up all the way back to our layered level, and I can see now the combination in the shader of the streak dirt and the discolored stone, so we're getting there. And then lastly there's a ramp dirt layer, and let's take a look at this. So again, this is a black dirt layer fed by transparency, and this is nothing more than a murky type of dirt applied, and this is using again a very subtle gradation of ramp here, and your intensities of the dirt will always be dictated by the values you place here on the ramp. Again, the ramp is really powerful through its noise functions. This is a spatial noise, and this is a hue, saturation, and value noise. In this case I'm using a value noise to add basically a randomization of dirt, or kind of a splotching of dirt within on the wall. So let's re-render this and see what we have from this whole shader now. Alright, so here's our final comparison of the original wall against our final weathered wall. And in this we can see the first of all, as we went through, the discoloration of the blocks based on the remap. We can see the increase in the increase in inversion of the bump map, both on the grouting here as well as the pitting throughout the wall. We can see the addition of the ramp dirt streaking down, or the streak dirt rather, and then kind of feathering off by the end. And then we can also see kind of an overall region of dirt throughout the wall as well, which was, I think that was called the ramp dirt. So these are just a few techniques, and again they can be applied to any model. Every probably texture has its own opportunities for things to do to it, but this is just kind of the basic start with how to weather your surfaces. So I think that should improve the look of your texturing. So at this point we're done talking about texturing and shading. Let's move on to our final project and show how some of the final shader work will be arrived at on it.